In this podcast, we're going to go over the parts of the mole map, and we're going to talk about how to convert from one unit to another using the mole map. All right, so I like to use this visual called the mole map in order to figure out how we're going to convert from one factor to another and what conversion factors we're going to use. If you're good with math, it's pretty easy for you to figure out what will I put on the bottom of my t-chart in order to cancel out the unit I'm trying to get rid of in order to convert to what I have. But if you're more visual, this is probably going to work a little bit better for you. So you're going to have to pause this in just a second. And when you pause it, I want you to make sure that you copy down the mole map. What you need to be careful of is that your color matches your arrow. For example, if I want to go from moles to grams, I'm going to use this conversion factor. So if I go in the opposite direction from grams to moles, I flip-flop those two. So notice we now have moles over molar mass rather than molar mass over 1 mole. So make sure that your conversion factor matches the direction of your arrow. All right, so we're going to go through the process that you need in order to use your mole map and your conversion factors. This is going to seem a little vague at first because we're not working it with an actual problem, but we will be applying it on the next couple of slides, so follow me. You're going to determine what you're starting with. So looking at the problem, you're going to get a number. Let's say they give you a number in grams. Then you're going to determine what you end with. Usually they'll say something like, what is this in molecules? Okay, so let's just say, for example's sake, we're going to end in molecules. So the last step is to determine your needed ratios in order to get to the end. So essentially, I'm going to look at this mole map, and I know that there is no way to go from grams to moles directly. I have no arrow going there. So what I have to do is actually go from grams to moles, and then moles to molecules. So I'm going to put that in. This is my intermediate step. You got to go through your middleman, the mole, in order to do this problem. So when I set up my t-chart, it looks like, because of these two separate arrows, that I'm actually going to have two different conversion factors. One that gets me from grams to moles, and another one that gets me from moles to molecules. So looking up at my arrows, I notice that this black arrow goes from grams to moles. So if I'm starting in grams, it tells me I need to use the conversion 1 mole over the molar mass, and as you remember, we do report molar mass in grams, so my grams will cancel, leaving me with moles. So I've made it to this step. The second step is to convert moles to molecules. So now I'm going to follow this blue arrow, which is going in the correct direction for me, and I'm going to plug in Avogadro's number, 6.02 times 10 to the 23rd, and I would like this in molecules, over 1 mole. Notice that my moles cancel. Again, if you're good mathematically, you know what conversion factors need to go on the top or bottom and what needs to be flipped. So let's apply this to some actual problems. All right, so this problem asks me how many molecules, that's what I'm trying to find, are in 4.0 moles of carbon dioxide. This is my given. Okay, so I am starting in moles, and I am going from moles to molecules. Okay, so that is a single step equation. So moles to molecules. So this will be a more simple conversion factor. So I'm going to start with my t-chart, and I'm going to start with my given, 4.0 moles, and we abbreviate moles, M-O-L. We just drop the, it's an abbreviation. Be careful not to do that with molecules because it would be the same abbreviation. We have 4.0 moles of CO2. Every single box in your t-chart needs to have a number, the unit, and the substance. Write that down, number, unit, substance. The reason for this, it's going to help you in stoichiometry. So we're starting to plant the seeds of stoichiometry. If we practice it this way now, it's going to be a lot easier when we do get to stoichiometry, and you'll see how we can change units and change substances also. So just get in that habit now. All right, so to go from moles to molecules, it looks like I'm using this blue equation. So I'm going to say 6.02 times 10 to the 23rd molecules, and I'm going to keep the same substance. It doesn't ask us to find a different substance. So again, I have number, unit, substance over 1 mole, and my substance is still the same, CO2. So notice when I cancel my units, moles of CO2 are going to cancel, and I will be left with the unit molecules, and again, the substance doesn't change. So whatever my answer is going to be molecules of CO2. So now we just treat this like any other conversion. 4 times 6.02 times 10 to the 23rd divided by 1 is going to give us 2.4 times 10 to the 24th. Notice I have 2 sig figs in my answer because the only number I was given had 2 sig figs as well. When you plug this number, Avogadro's number, into your calculator, be sure that you're putting parentheses around the whole number, or else your calculator is going to start to multiply or divide exponents, and you're going to get all kinds of wrong numbers, so be careful of that. All right, the next question asks me how many moles, so they're asking me to find moles, are in 3.0 times 10 to the 23rd atoms of gold. Okay, so it looks like we're starting here with atoms, and they want us, they just want us to go to moles, so that's a one-step problem. So I'm going to set up my t-chart. I'm going to put my given on the first line, 3.0 times 10 to the 23rd atoms, telling us that we only have one single element of gold, AU. All right, so to get from atoms to moles, I'm going to use this red equation where we have 1 mole of gold over Avogadro's number, 6.02 times 10 to the 23rd atoms. I'm maintaining the same unit and the same substance. So what's going to happen is atoms of gold are going to cancel, leaving me with moles of gold. That is what the question asks, so I know that I'm done with my conversion factors. I don't have to put anything else in. So now we are going to plug in 3.0 times 10 to the 23. Make sure you use those parentheses times 1, and then divide it by Avogadro's number, 6.02 times 10 to the 23rd. And the answer you should get rounded to 2 sig figs, because we're using the multiplication and division rule, is going to be 0.50, this is a significant 0, moles of gold. All right, so let's work a couple more problems. This time we're looking for mass, that's what's our unknown, of 5 moles of nitrogen gas. So we are going from moles to grams, so we're going to be using the green equation as our conversion factor. Okay, so this is only one step because I'm going from moles to grams. So I can set up my t-chart. I know I have 5.0 moles of N2, and it tells me the conversion factor is molar mass over 1 mole. So I know that 1 mole of N2 is going to go on the bottom because I want those to cancel. But what I don't know is what the molar mass is. So you're going to have to look at your periodic table for nitrogen, and I know that the mass rounded to 4 sig figs for nitrogen is 14.01. But that it is a diatomic element, and I have 2, so the molar mass of nitrogen gas, N2, is 28.02 grams per 1 mole. Remember, this is a ratio. Well, if we look at what we already have established, we've established that it's grams per mole. We can just plug in the molar mass on top, 28.02 grams of N2, and we're actually using the molar mass as a conversion factor. Okay, so molar mass over 1 mole. Moles of N2 are going to cancel, leaving us with grams. Double checking my problem. Grams and mass are the same thing. That's what they wanted me to find. I can put an equal sign and solve this problem. So 5 times 28.02 divided by 1 is going to give you 140 grams of nitrogen, N2. So I went ahead and rounded to 2 sig figs because we're using the multiplication rule. So make sure that you're being really careful if it needs a 0 as a placeholder, that you're actually adding that in there. And again, number, unit, substance every single time. All right, let's do this next problem. They want me to determine the mass, that's what I'm trying to find, in 2.56 times 10 to the 25th molecules of sodium sulfide. And they gave me that. That was kind. All right. So I am starting in molecules, and they want me to go to grams, which is mass. Well, here's molecules, and here's grams. That's not a one-step problem. I'm going to have to go and convert this to moles first and then to grams. So I now have a 2-step problem, but that's okay. We can do this. So let's start by writing our t-chart. and writing our given 2.56 times 10 to the 25th molecules of sodium sulfide. All right, so my first conversion is from molecules to moles. So I am following this red arrow, molecules to moles, and that tells me I'm going to put Avogadro's number on the bottom because I would like to cancel molecules of sodium sulfide. So it's going to get wordy. And that is per 1 mole. Remember, those are equivalents to each other. All right, so with that, I've canceled molecules and I've been left with moles. So I made it to this step. However, we're not done. We're going to have to do one more conversion. So I'm going to continue my T-chart. Now that I have moles, I would like to go to grams. So I'm going to follow this conversion factor where I put 1 mole on the bottom because I would like to cancel moles. And then I'm going to write the molar mass on the top. So in order to calculate the molar mass, we are going to need to add up all of the elements involved in sodium sulfide. So that's 2 sodiums. Okay, so 2 sodiums would be 22.99 times 2 plus 1 sulfur. Sulfur is 32.07. You should get a total of 40.08 grams. Okay, so molar mass is 40. Oh, I'm sorry, that's not the right molar mass. 78.05. That's what you get for using notes and not a calculator on hand. All right, I thought that seemed a little low. That seems more like calcium. That's what it is. I looked at the wrong one. All right. So 78.05 grams of sodium sulfide. My moles of sodium sulfide cancel. I'm left with grams. Great, because that's exactly what it asks me for. So now I'm going to multiply 2.56 times 10 to the 25th times 1 times 78.05. I'm also going to multiply across the bottom, and then I'll divide the top by the bottom. So what you get at the end should be 3,320 grams of sodium sulfide. Okay, I rounded to 3 significant figures because I was given 3 significant figures in my original problem.